Hello, and this video is about drawing parametric graphs with the fx-CG50. So just to give you an idea what I'm talking about, I'm talking this graphical calculator. Now, if you have one of these, this is where this calculator is an advantage at A level. You don't have to have this calculator for A level. Many go into the exam without it. But having it, there are definite advantages to, if you can pay the premium for it, to actually answering some of the questions. So here we are going to talk about parametric graphs. And so sketching parametric graphs. Let's just make that a little bit clearer for us. So we saw, and one strategy for sketching parametric curves is to convert it into a Cartesian equation. Yep, that does work sometimes. And hope this is a form we recognise, so a quadratic or an equation of a circle to appropriately sketch. However, some parametric equations can't easily be turned into Cartesian form. So this is where the examiner may wish to challenge you and see if you could sketch a particular graph. So here we have the graph of x equals theta cos theta and y equals theta sine theta. So just zoom in so you can see that a little bit more clearly. And it's between values of theta between 0 to 4 pi. Now, these parametric equations in Cartesian form would be the square root of x squared plus y squared, which is also equal to arc cos of x over the square root of x squared plus y squared. Now, I'm sure you've already sketched that out and you won't need my advice at all, but if, like me, that looks a little bit challenging, this is where you're going to find that a combination of, yes, you're going to have to do a bit of maths, but your calculator as well, it will give you an advantage. Now, first of all, I'm going to show you the way everyone else has to do it. So here we go. This is what you're asked to do. You're asked to plot this. You're going to write down your values. It does say from 0 to 4 pi, but here it's just done from 0 to 2 pi. You can happily carry on. And you are then going to work out by substituting those values in to x, you'll get some answers. And so substituting them into y, you'll get some answers. And then you'll plot x against y and get this beautiful graph that's down here. So when we're plotting it, just to give you the idea, here are your values, and then you're going to plot them. And there we go. Now, yes, putting these in is all fine, but really gets quite hard for you to plot that and looking at those to get a feel of the shape. So, yes, I want you to be aware of that and be able to do it because the examiner could test you in a way where your calculator isn't always so great. But now let's have a look at what we do if you do have the calculator. So here's our calculator. Well, first of all, I do need to check that it is in radians. And if you've forgotten how to do that, it's Shift and Setup. Now, it can be best, if I'm honest, to do this in Run Matrix. So let's go into Run Matrix, and you can see that I am in radians at the top here. But if you're not, Shift and this menu, which then gives me Setup, and I can scroll through and put it into radians. So you might be in degrees. So having checked we're in radians, I go back to my menu. Now I am going to want to draw a graph. So I tapped on that too quickly. I'm going to want the graph. So I scrolled to graph, and there we go. Now I'm going to delete what is already in there. And up will come this, but it won't for you to start with. It's because I've already been in here. What usually comes up is this. So this is how I would expect yours to look when you turn it on. So you should have Y1, Y2, I wouldn't have thought there'd be a naught there, so let's delete that. But it should be something like that. If you do have anything in here at the moment, make sure you delete them. And if you've forgotten how to do that, just type on it, move the cursor up and down and press delete. Now, we want parametric. This is for your Cartesian graphs where you have y equals. You haven't got that. So along the bottom here, you'll see type. So click on that and it says param. Param is parametric. So we're now going to change it to parametric. And you need to check that you've got something with X and Y because as you remember from what we've learned already, parametric graphs are in terms of X and Y. You're now going to type in your equations. So we've got X equals theta cos theta. So here, this is where I'm going to get my theta from. It comes up as T, but it doesn't matter because we can use any variable. So it's T cos t, which is fine. And here I want theta sine theta. So on here, that will be T sine t. And I'm going to draw. Now, that looks lovely, but it doesn't always quite work like that. Mine's worked because I've set it up to. But let's go back. When you go back into here and we actually get up the graph for the first time, you may have your settings like this. And actually, it does work quite nicely in initial. Let's try other ones. Standard. Again, it does work, but it doesn't quite look like this, but it is giving you the idea. Now, we want actually trig settings because that's where it says trig. And you start to get the right shape. And you're starting to see this happening. And it's giving you that clue to help you in the exam when you're trying to plot this to know what to look like. And you can then, if this view window, by the way, the view window is the place you change your scale. So we have the initial scale, the trig scale, and the standard scale. And as you can see, different scales give you slightly different views. But what it's allowing you is to get an idea of what that graph will actually look like. And you can scroll down a bit. So here we go. I'm using the cursor button just to move down. Now chop the top off. So I might want to do something called zoom. And you can see that there's zoom here. So what do I want to? Do I want to zoom in or do I want to zoom out? Well, I want to zoom out. It says select center position. So I actually want to zoom out. I'm thinking I'm going to make that my center. Might be a little bit high, so bring it down. And then I'm going to go execute. And look, I've got it. And I'm now starting to see their graph. Now, because it says 0.44 pi, I can go in here and I can say, well, I'm going to actually alter this scale to get that information in there. I'd have to think about what's happening between 0 and 4 pi as I work through here. Okay, so you are going to need to do this, but the benefit is you have your calculator to actually help you find the shape of the graph there. Now, that's quite a lot of information that I've been clicking around on the calculator. We're going to do another one now, but it's really key you understand how to use your calculator because we're doing parametric curves at the moment. In about 2 months, you'll have forgotten how your calculator works. So it's worth having somewhere you write these little notes of how your calculator works. Because if you understand how to use this, you are at a significant advantage. But students often go in with this wonderful calculator but don't know how to use it. So here we go. Draw the curve given by the parametric equation x equals 2t and y equals t squared. So I'm going to exit. I'm going to delete my formula so it's now all clear. So x, that's equal to 2t. And y, that's equal to t squared. Now I'm going to draw. I don't know whether that's the final graph. What I'm going to do is check my view window because at the moment I'm not sure if I was in trig scales or standard or initial. I'm going to click on initial. Let me see what I get. Still a curve. I'm just going to come back. Does it help me anymore if I view window, look at standard? Does that give me a different view? So I'm looking like I've got a curve. Now this is where it is really worth you drawing out your values. So here's my values there. So if I'm looking, this does actually look like this is a graph that is a quadratic, because if you look at that, these look here, and it is possible it's going to have that curve because we have got the t squared. I'm just also going to look at this scale. So let's see if that will help me. X min now, having got these values, I now know that's -2. X max, I'm going for 10. Let me just go back to that. Oh dear, no. And I'm just going to go back to the view window. Y min, so what's the lowest value of y? It's 0. I'm going to allow for -1 just so I can see it go below. And it goes up to 25, so I think I might go up to 30. Don't know what this will look like. Let's see. So it's very much looking like a curve. Whatever I do, I'm getting that curve. And if you look, that's also what they've got. But they've got that slight kick up, which I may have lost a little bit by my scaling. But this calculator's helped me get an idea of what I'm expecting, and that's what you're using your calculator for. So now the thing to do is have a go at some questions. As I said, you're going to need to do this, but you want to use your calculator in the parametric form to check that the shape that you get on your graph is also here, so that you're getting an idea from your graph, your calculator, what you should be expecting. Off you go, practice away.